Hi, welcome to my presentation. In this video, I will discuss the points in 3D space, vectors for direction and movement, and matrices for geometric data manipulation. But before we move on to the topic, it is also important to understand the concept of 3D space. Let me define first what is a 3D geometry. The three-dimensional geometry involves the shapes of mathematics and is used to represent either point or a line. Also, it can be a plane in a 3D space. It is somewhere similar to that of the two-dimensional coordinate geometry. The three dimensions point in a 3D space involves the x-axis, the y-axis, and the z-axis. Across all three axes, there are mutually perpendicular with one another with the same units of length. There is a requirement of the three parameters in a third space to find out the exact location of a point. Like the two-dimensional coordinate system, the origin is present, which is the point of intersection. The space is divided by these axes into 8 octants. It is essential to know that the points are separated by a comma and are written under parentheses in a Cartesian coordinate system. In 3D geometry, the point is represented either on a Cartesian form or a vector form. In a Cartesian form, in the three-dimensional geometry, the representation is done using three coordinates: the x-axis, y-axis, and x-axis. So, the coordinates in three-dimensional geometry are x, y, z. The point of x value is your abscissa, the y value is known as ordinate, and the z value is known as applicate. The representation of a point P in the vector form is a position vector OP. It is written down in a form of OP is equal to xi plus yj plus zk, where I, j, k are denoted as the unit vectors and the x-axis, y-axis, and z-axis respectively. In this section, I will discuss vectors for direction and movement. A vector is a quantity which has both magnitude and direction. Examples of vectors include displacement, velocity, acceleration, and force. To fully describe one of these vector quantities, it is necessary to tell both the magnitude and the direction. For instance, if the velocity of an object were said to be 25 meters per second, then the description of the object's velocity is incomplete. The object could be moving 25 meters to the south, or 25 meters per second to the north, or 25 meters southeast. To fully describe the object's velocity, both magnitude and direction must be stated.